Hey everyone, welcome to another episode of GenAI Vlog. So today I want to walk you guys through how I set up RunPod and what's gonna be the necessary thing for me to do to get everything started before I fine-tune my own large language model. So to set things up, here I have already created a RunPod instance. Here's a pod I created. And once you create another one, obviously it will show up here. This is up and running, meaning that it will already start charging you money. Here's a button that's called Connect, and you can launch your own Jupyter Lab, which give you Jupyter Notebook, terminal, things like that. Or you can just start a terminal directly, and then you can run this in a terminal. So all that it's up for grabs. And on top of that, you can do SSH. If you want to log in locally, you can control from there. So this is a demo purpose. Obviously, after the video, I'm going to shut this down. And for that matter, all these names, IDs are going to be deleted. So just to keep everything safe, everything kosher. And that's pretty much all the way. That's pretty much what we have in the beginning. So let's take a look at what's going on, right? I'm using this image. That is the image that I've been using, Python 3.10, Torch 2.1, CUDA 11.8, and on top of that, I'm running this on Ubuntu. I have four GPUs, right? Four A100 GPUs. That's the size of the RAM. All that's pretty straightforward. On top of that, I have 20 gigabytes for the disk, and I have the 500 gigabytes network volume. So this network volume, obviously, you have to pay for that, right? Pay for that additionally. I believe this is something like a few dollars per month. So with that being said, we can then hit connect, and then we can go into our Jupyter Lab. So this is gonna start off with Jupyter Lab, very straightforward. There's a Python notebook, console, things like that. For the sake of this video, I'm gonna do everything in terminal. So this is the image, right? RunPod image, and this is the terminal right now. I'm on working directory workspace. So let me clean this up a little bit. Let me zoom in. The first thing I'm going to do is I'm going to pip install UV. UV stands for Universal Virtual Environment. It's a famous package for you to essentially control your environment, Python package, things like that. Here's a cheat sheet if you're interested in, right? If it's the first time you're looking at UV, then obviously you can fresh yourself up for that. Once it's installed, then I'm good to go, right? So let me list out what's going on. It's empty. On the left-hand side, you don't see anything. It's empty, so that makes sense. We're going to initiate a package. Just going to call a project, PROJ, and then you see a folder, right? We're going to go into that folder. Now I'm going to work on everything within here. Right now, there's not so much going on, right? Let's take a look at the main.py. Not so much is going on, just, hello world. And then let's take a look at the PyProject homo file. Again, not so much is going on. Dependency is empty. We're going to add dependencies, right? So here's a dependency that we will be adding. I'm going to paste it here, and then I'm going to explain it first, right, before I run. I'm going to try to update Torch transformers. That's all just base understanding. And all that is just the fundamental package we're going to run. Transformers that work with Hugging Face. Accelerate, it's working with Deepspeed. Datasets allow me to download datasets from Hugging Face. And obviously, Deepspeed is the one thing I will be using to manipulate multiple GPUs when I'm fine-tuning model. On top of that, I have bits and bytes that I always install along with Deepspeed and transformers, just simply because sometimes I'm storing model weights in 4-bit, 8-bit, things like that. TRL stands for Transformer Reinforcement Learning. It will give you the reinforcement learning module, right, such as GRPO, things like that. So that's great. Let's install that under UV, and then this will resolve the dependencies, install all the packages, and then make sure everything's kosher, make sure dependency conflict is resolved. And then after all this is done, I'm going to show you guys a tree of dependencies. Then that will make everything clear. For time being, I am going to change the theme to dark just to go easy on our eyes. So once everything is done, let me clean this up and then let me present you the tree structure. So if you do a UV tree, this will display all of the packages along with dependencies that it's using. So UV tree, we have 98 packages that we resolved, and then starting from accelerate, right? And then here we have torch, and then underneath here, bits and bytes, we use NumPy and torch data sets. That's from Hugging Face, Deepspeed. Deepspeed rely on pydantic, things like that. Torch, transformers here. Hugging Face Hub is part of requirement for transformers, things like that. All that's straightforward. One thing I want to point out is if you use pip install, you might have a little difficulty installing this transformer and get it to work with up-to-date package of Deepspeed and perhaps even Torch. So with that being said, that's all I have. I think right now I'm good to go. So I have all the packages. Let's examine the PyProject Tomo file just a little bit more. And here are all the files. So now I'm ready. First thing I need to do is to create a config file. So I'm going to call that dsconfig. I'm going to call it 01. This is to use stage 1 sharding when I'm running Deepspeed. So in that sense, I'm going to copy everything here. Let me walk you through just a little bit, right? We have training batch. These all set to auto. We're going to enable floating point 16 stage here for optimization. It's set to stage 1. That means level 1 sharding. And then all these other parameters pretty much up to date with what I'm running Finetune large language model. So with that being said, let's end the file. I might have made a mistake here. Let's take a look. Say edit. Oh, I think I'm good to go. Okay, so perfect. Now let me clean that up. The next thing I need is a Python script. Python script now needs to call this JSON file as a configuration file. So concatenate eof, and I'm going to call this trainds.py. Paste everything here, eof. So that creates this train_deepspeed.py file. So let's refresh. Let's go in there, take a look what's going on. Import, that makes sense. Here we have a base model coming from DeepSeek, and then we have a dataset. So I previously already fine-tuned this model against this dataset already. So what I'm going to do is I'm going to take my already fine-tuned model. So it's not going to be this model, right? Because I already fine-tuned that. I'm going to give a new model name. So I'm not wasting money, right? This is the already fine-tuned data set on this data. And then I'm going to give a new data set. Okay, so this new data set, let me show you guys a link. It's called Code Alpaca 20K. This is enhanced with the COT, chain of thought. And the chain of thought is generated by DeepSeek model. This code Alpaca, that's coming from here. So you get the idea, right? We're not talking about rocket science here. These are just basic coding questions. Create an array of length 5, blah, 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 and then that's an array of length 5, right? Formulate an equation to calculate the height of a triangle given the angle. Here's the formula, right? Write a replace method for string class, which replaces the given string with a given set of characters. That's definition of the Python function, return a string, things like that. So you get the idea, right? So the only thing this data set does not have is the reasoning, right? I'm looking at output, instruction, input. If you have any, that's pretty much it, right? So the only novelty that I'm doing here is to create this new column called chain of thought, right? COT. So in other words, what I need to do is I need to process data in a way that instruction input obviously go together. You can call that like a question tag, right? And then you have a COT, that's your reasoning tag or think tag, right? Like what I have here, bracket think. And then you have your answer, that's the output. So we need to basically do a little bit of data processing to make sure that the data schema is kosher for exactly what we're trying to do. And then we're going to do that here. So what's going to happen is I am going to use this path. And then I'm going to put that here. So that's going to be the new data, right? This new data. And then I need to reprocess this just a little bit. So what's happening is I am going to grab, I'm going to change this tag to question. And then we're going to end on bracket question as well. The middle is going to be think. So I'm going to make sure that the think is kosher. I'm going to do think tag. And then in the end is obviously going to be answer or response. Let me just make sure I have the correct tag for myself. Let's see, what did I have? I have, I believe I have a response. Okay, so let's just make sure this is correct. So response. Let's make that there. And then here we're going to say bracket / response. Okay, so now I have the schema. Now I need to make sure what's inside of this string is exactly what I want, right? For example, question. Question should be instruction and input. Okay, so these two things together, that should be the question. So I'm going to call it instruction. And then here we should also have example input. Let me make sure instruction is here, input is if you have it, right? If you don't have it, then that's empty. But in this case, if you have it, then you have a string with hello world, things like that, right? So you got to put them together. Instruction first, input second, that forms your question. Now we have the think tag. Think tag is a COT. So COT, that's the example COT. Let's think about it step by step. That's fine. We're going to put that here. And then that wraps up the reasoning. And then in the end, we have the answer, right? The output. Output is this column, output. So what we're going to do is we're going to call that output. So output is wrapped in response. And then I think the way that this data set is processed is sometimes there is think tag and then there is response. So in that case, I am going to just do COT and the response is concatenated in the end along with the think. So in this case, I do not need output column. So in that case, I think that's the scenario where you have think, you have the other scenario, which let me take a look at this one. This one is just reasoning. Oh, there's a little bit of response. I guess there's a thing here as well. Think is here. So in other words, we don't need. So in other words, we don't really need the output column. So let me just make sure there's the height of a triangle, and somewhere down here should be height of a triangle. Okay, so we don't need answer, so we can kill that. And then we also don't need this thing tag because all of it has thing tag already. And then we can pretty much omit this. So it would just be like this. And then that is probably it. That should be it. So once again, question, that process has instruction and input. That's because we have two columns, right? And then the COT is because the third column has the think, right? Think tag here, close the think tag, and then response here, close with response. And then let me go to a different sample. Same thing, right? Think tag here, response here. And then if you have think tag up here, that's here, reasoning, concatenated with your final response down here. Great. So that's the structure. So we don't need this first column output. We just need a COT, and then the reasoning is all here. Great. So that gives us, that defines this prompt on line 51, and then it goes into this dictionary and just call that text, right? So now it becomes text generation, right? Everything is in one big string, and then the question, reasoning, and answer are basically separated by these tags. These tags, I'm talking about these brackets, right? Bracket question, bracket think, bracket response. Okay, that's it. We're gonna have the tokenizer set up, return tokenizer. Okay, we're good. I'm gonna make this a little bit longer, 1024. Truncation to be true, that's great. The thing we're gonna tokenize is the text, right? That makes sense because here we're returning this text. Okay, so everything makes sense. The map just configurates it so we have a processed training data. So after line 79, we have a training data that's post-processed. We set our format, right? We reformat it so that we get our attention mask out, get our input ID out. So this gives us the correct tensors. And after that, we can train our model. So in the training argument, everything is pretty much consistent with what we have been consistent with transformer. The only thing that's different is we're going to use the Deepspeed configuration, right? Everything else is the same with transformer on Colab or whatever, right? The only thing different is Deepspeed. Inside of Deepspeed configuration file, you want to make sure you're pointing to that JSON file that we talked about before. So dsconfig01.json, that is here. That is pointing to here. That's this file. So that's in the same directory, obviously. And then we don't want to report to anything, right? Unless you have weights and bias or other platforms, you can report to those platforms. You can track the performance, things like that. But in this case, we're going to bring everything on our console, right? On our terminal. After that, we are good to go, right? Throw everything in a trainer, and then we can start training. Afterwards, we want to save it somewhere, right? So model save, tokenizer save, right? We want to save in a place where it makes perfect sense. So this new model is going to be it's going to be DeepSeek R1 distilled Quinn 1.5 billion, and this is going to be by code Alpaca 20K. So what I'm going to do is I'm going to not change this, but I'm going to change this. I'm just going to add code Alpaca up here. So what I'm going to do is I'm going to grab this, and then I am going to put it here. So that means that this model has seen these two data sets before. And I'm going to make the small case just so that I know that I touched this file, and this is a unique name, right? And then what's going to happen is it's going to save everything in this path, right? This path is basically OS join eagle 0504 and here. So we're expecting a folder called eagle 0504. So we're expecting a folder called eagle 0504, and then we expect everything to be in there. Great. So what I'm going to do is I'm just going to do one epoch so that you guys can see what's going on, hopefully in a short amount of time. And then after that, let's not waste any space. So save steps 500. Let's make that to some crazy number so that we don't really want to save anything, just so that we can, train it and then save it once. To make that a bit more secure, to save total limit, we're going to set that to 0. And then I think we are good to go. So it's just going to train one epoch, and then that's going to be it. Great. So now once that's done, let's make sure the training script is set up correctly. We're going to open that up, and then obviously all this need to be changed. So I have something here ready to go. Boom, just like that. The command we're going to run is Deepspeed. The parameter is num.gpu equals to 4, and then the training ds is the Python script that we just talked about that has all of the artifact inside that allows us to train everything. That's what we need. Let me just make sure that I have watch open. So we're going to flash this every 0.1 second, and then we're going to watch it with the NVIDIA. So we have 1, 2, 3, 4 GPUs. So this main.py script says 4. That makes sense. Everything else should be okay. Now we're ready to go. So let's rock and roll, right? So we're gonna do uv run main.py. Let me zoom out just a little bit, and then we're good to go. Right? So I'm gonna hit enter. This should kick off the main.py script, which then is going to execute training ds.py script using Deepspeed command. So wait a little bit, and then what we also going to do is we're going to open a new terminal, and then we're going to instantiate a watch section here. NVIDIA SMI. It's going to watch the 4 GPU. If it's training, if it's going smoothly and correctly, we should expect the utilization rate of all 4 GPUs to start to pick up, right? If we're going to be using something, then this should not be 0%, right? It should be like 80%, 90%, high 90%. That means we're using these 4 GPUs. So let's give a minute and let's come back to here and let's see what's going on. Okay, let's come back to this. As you can see here, now these utilization rate have picked up, right? High 90%. That makes perfect sense. That means we're using these 4 GPUs. Let's come back to this terminal. Now this progress bar is up and running. We're not talking about a whole lot of epoch. We're talking about one epoch looping through over 600 steps. So this is going to sing all the data once, and then it's going to be around 10 minutes, and that's probably going to be it. Right now, I'm looking at 9% finish of the progress bar, so it's going to take a few minutes. And as you can see here, we have one row of loss being printed, and we're starting this loss being 0.91. And then the grade norm, and then the gradient norm is 0.69. Learning rate is 4.75. This is by a scientific rating. This is by a power of -5. So we're talking about 0.000004, something like that. And then the epoch is 0.08, right? So one thing to note here is epoch is actually a fraction. I assure you this is not a mistake, right? Because we are looking at the epoch in terms of batch size. And then batch size is usually very small number. We're not fitting the model through all of the samples all at once, right? We're going in batches. And then each batch, we're talking about a portion of the data set. And henceforth, we have steps being divided so that as it's moving towards that one epoch, there are a bunch of things in the middle being printed. So this is not a mistake. It's meant to happen. And then last but not least, the loss, hopefully it's going down, right? Here we're looking at 0.91, 0.54, 0.52, so on and so forth. Obviously, the idea is if this thing go many epoch, right? 10 epoch, 20 epoch, 100 epoch, something like that, you expect this number to go down. Based on my experience, you want this number to go down to 0.01, 0.02, something like that, to basically be confident that the model has seen all the data and has memorized it correctly. You pretty much want to get to that point. And since this is demo purpose, obviously in a few minutes, we're going to come back to here. We're going to show you what this look like. But with only a few minutes, I'm not expecting this to go down to 0.01. It'd be pretty magical if it does. And then um, and then before we go on a small break, we're gonna go up here and just point out a few things. In the beginning, it's gonna set up a list of steps of configuration, right? These are all just the accelerator trying to be configured with 4 GPUs. That's why here you see 4 CUDA devices that's up and running with the rank 0, 1, 2, 3, 4. That's just to track each of the GPUs, and they are up and running. Then there's no error here, right? It's just said, hey, we're setting up this process, and that is the rank. And then on top of that, we're gonna run the script, right? We're gonna physically execute the script. So these are just logging infos, loading the tokenizer, loading the model, and then we run the tokenizer. Here's a config, here's a token, we map the token, right? These are just steps that we have been seeing from the Python script. Like for example, here we have setting up torch format, things like that. Okay, welcome back. So we wait a little bit. Now the training has finished. Here we see the progress bar has completed. And then we finish with one epoch. So here I saw the loss to starting from here, the loss started from 0.9 and it went all the way down to 0.46. So we are making progress, right? We are making progress. I'm expecting maybe not a whole lot, right? 10, 15 epoch, we should probably drop this. We should probably be able to drop this loss to maybe 0.2, 0.3, something like that. And that should be already a pretty good training process. And then in the end, I just want to show you guys what the model is. I want to show you guys where the model is. So let's list out all of the directory. Let's go into Eagle 0504. Let's see what's in there. Here we have OpenAI GSM 8K, code Alpaca 20K. That is the file that we just saved, right? Let's go into our Python script. OpenAI GSM 8K, code Alpaca 20K, enhanced DeepSeek R1 distillquent, blah, 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 right? That's it, right? That's where we save the model. That's in there. And then if you go into that folder, you can then list out the directory. You see tokenizer, you see model, the weights are here. So we're good to go. We've trained the model. Model has seen this data set. And what I'm going to do is I'm going to do 15, something like that. And then I'm going to release the results online. Like, so there you go. It's a bit of a technical video and might be tedious, but hopefully hopefully this video is helpful for some of the audience. Hopefully you like it, and I'll see you in the next episode.